Yo, what up, first period? Sorry that I am bailing on you today, but I'm headed to Nashville for a baby shower. And you might be wondering, what the heck is Mr. Smith doing on a gorilla taco, sweet potato taco? So here's what I'm telling you. I'm so sad that I'm not there to teach this lesson that I'm going to teach you two things. One, I'm going to teach you how to expand and condense logarithms. But two, I'm going to show you one of my favorite recipes of all time. I absolutely crush this recipe at least once a month, and I almost can do it without looking. It is delicious. This is from my guy Roy Choi, chef, from the no problem, chef off of Netflix. But check this out. Actually, that's my teaser. At the halfway point of this video, we're gonna come back to these, and I will show you the secret. All right. This is, we did these notes together. We kind of talked about the introduction to logs. We talked about how an exponential equation and a logarithm equation are inverses. That's important. They kind of undo one another. And that's actually an important concept when we jump into the laws of logarithms. Because you already know this law. You know exponent laws. You learned those in Algebra 1, Algebra 2. When you multiply something with the same base, you add. When you divide something with the same base, you subtract. When you have like a power raised to a power, you multiply. Okay, those are exponent laws. Let's take those and put them in reverse to get our logarithm laws. Here's what I mean. When you were multiplying, you added. When you were dividing, you subtracted. When you were raising a power to a power, you multiply. Take those ideas and check this out. See if this makes sense. The three rules. The first one is called the product rule. And what the product rule says is that if you have a logarithm, it can be any base, so I'll just stick a random 3 there. If you have a logarithm of two things being multiplied, let's just use x and y. It could be anything there. It could be 6 times x. Could be a times b, could be 1/2 times 5, whatever. If you have a logarithm of something being multiplied, aka a product, then what you can do is you can expand that into multiple logarithms being added. Log base 3 of x plus log base 3 of y. Didn't we just say with exponent rules, when you're multiplying, you add the exponents? Well, it's the same with logarithms. When you are adding two logarithms, what you could do is you could multiply and combine to 1. You can go both directions with this. Sometimes you start here and you expand it to multiple. Sometimes you start with multiple and they want you to do the rule in reverse and pack it into 1. You got to be able to go both ways. But ultimately the rule is if you have two logs with a plus sign in between, you can combine them together, and they have the same base, by the way. They both have to have the same base. But if you have two logs with a plus, you can combine them into one log with a product. Next rule is the quotient rule, and it's very similar, but it's with subtraction and division. If you have a logarithm that has division, x divided by y, then what you can do is you can break it into two logs with subtraction. Very similar to the exponent rules. Once again, they have to have the same base. So that's the product rule. It can go both ways. You got to be on the lookout for minuses. If you see two logs with a subtraction sign between them, you can combine them together. If you see two logs with a plus sign in between them, you can multiply them together. Then the last rule is called the power rule. And that rule tells us that if you have a log, let's just stay with what we've been doing, log base 3 of x to the third. The power rule tells us that that exponent, instead of becoming an exponent, moves down front to be multiplied together. So it would be 3 times log base 3 of x. So notice what happened. This power came down front to be multiplied. It's no longer an exponent. That's called the power rule. So wait a minute, you're saying when there's a number being multiplied by a log, it can go back and be an exponent. Kind of like when you had an exponent raised to an exponent. What did we do? We multiplied. So multiply. Okay, I'm seeing a connection. I'm hoping you see the connection, because logs and, like we said, logarithm functions and exponential functions are inverses, so they share some of the same qualities. Let's practice, and then let's go look at our tacos. I'm hungry. This says evaluate the expression. So this, when you see, okay, there's three things. There's evaluate. That means solve. You're going to get a number answer. There's use the laws of logarithms to simplify. This looks like we're going to be condensing. Because look, there's 1, 2, 3 logs. I'm going to pack it down into 1. There's 1, 2, 3 logs. I'm going to pack it down into 1. But then down here, you can see it's expanding. It's just one logarithm, but I'm going to break it into multiple logarithms. Okay, that's my job. Evaluate, condense, and expand. So, first evaluate. 2 to the what power gives me 6? I have no idea. But what I do see is I see 2 logs separated by a subtraction sign, which means I can write those as one log with division. Okay, and now I have 2 logs with a plus sign in between them, which means I can write them as 1 log with multiplication. So 6/15 times 20, 6 times 20 is 120, divided by 15 is 8. Hey, what do you know? 2 to the what power is 8? The answer to this is 3. Pause that video, go back and watch. What I did is, I'll use purple, is I did the quotient rule right there to combine those because of the minus. I did the product rule after that to get it down to 1, and then from there I did what we did yesterday, and I went around the world. 2 to the what power gives me 8, and I found the answer was 3. That's a question mark. 2 to the what power is 8. Alright, let's evaluate this one. Ooh, tricky. What do I got here? I see an exponent. So can't that go down front? Isn't that the power rule? So let's rewrite that as 100 times log base 4 of 16 plus, let's go ahead, since it's all plus, the order doesn't matter. Let's combine those. 2 logs with a plus sign. Power rule says I can multiply and turn them into 1 log with a multiply with 6 times 2/3, 12 over 3, that's 4. So now I'm here. I think I'm ready to simplify now. 2 to the what power is 4, that's 2, so that turns to 2. 4 to the what power is 16, that's also 2, so it's 100 times 2 plus 2. So that's 200 plus 2, that equals 202. So I had to use a power rule. Oops, I had to use a little power rule there. I used a product rule there. I then just started simplifying. Okay, that's evaluating. I'm still using the rules. All 3 of these use the rules. Get comfortable with these. You're going to be able to practice in the textbook. The pages are actually clear this time. You'll be able to practice these rules. Okay. Use the laws of logs to simplify. We're condensing. I see a logarithm. I see that plus sign and that minus sign are what stand out to me, as well as this 2. I'm going to use a product rule, a quotient rule, and a power rule. Check this out. First thing I'm going to do is take that 2 and move it up here to become an exponent. So this will be minus natural log of c squared. Now I see that these are being multiplied. There's a plus sign, so they're going to be multiplied. So that's going to turn into the natural log of a plus b times a minus b. So that's a squared minus b squared. Ah. So I did a little product rule action right there. And now I still have 2 logs. So I'm not fully combined. You're not done until you're down to 1. 2 logs with a minus sign. So that's going to be 1 log with division. So the natural log of this divided by this. fully condensed in. I had to use all three rules there. I used the product rule. I used the power rule right there to bring that exponent up, and then finally I used the quotient rule. Next problem. You're just learning by examples here. I see this in front. I'm going to move it up here. I see this 2. I'm going to move it up here. I see this half. I'm going to move it up here. Do you remember what 1/2 as an exponent is? Remember, it's the same thing as a radical, as a square root. So this would actually be log of the square root of x plus 1 minus the log of x squared plus the log of what's x squared square root. That would just be x. So now I'm here. Now I'm looking, I'm like, okay, I see 3 logs still, but I see a quotient rule that's about to happen. And then I see a product rule that's about to happen. I like to do the product rule first. So let's just go left to right. There's no parentheses. So this is going to turn into log of this over this plus the log of this. So quotient rule. And then product rule, so I'm multiplying. So the order did matter there. If this was grouped, that's one thing, but it wasn't. It was just straight left to right. So my final answer will be log of, notice, 1 log plus another log. So I'm multiplying. So that would put that x on top times what's already there over what's already there. So these ramp up in difficulty, but that is condensing. Notice if you're ever condensing, your final answer is ready when you've done 1 logarithm. Expanding, move on. Expanding, you have to break it up. And here's, you start to get an eye for these kind of things. I see a natural log, I see an x squared, I see a y, and I see a root of a. I'm assuming I'm going to have 3 logs when it's all said and done. I see a division bar, which lets me know I'm probably going to use the quotient rule and use a minus sign. I see x squared times y, which means I'm probably going to use a plus sign and a product rule. So I'm going to do it all in 1 step and see if this makes sense. I'm going to have 2 steps. Natural log of x squared plus the natural log of y. Why did I choose plus? Because that is a product. But then I need to do a minus natural log of the square root of a. So first step, I now have it expanded almost all the way. The only thing that I have left to do, I've done both the product rule and the quotient rule. I need to do the power rule. This 2 goes down front. 2 times natural log of x plus the natural log of y minus, what is the square root of a? Remember, that's a to the 1/2, so I can bring that 1/2 down front as well. That is now fully expanded. This one, real quick, has a 5. I bring it down front first because look how that's grouped. So now I'm here, and now I split it up. 5 natural log of x plus 5 natural log of y. So I did the power rule and then I did the product. You use these 3 rules. Keep these notes close by you. Okay, keep these locked in. Use these examples. Watch this video again. But honestly, the more you practice, you start to get an eye for the order, how to expand. Oh, it's division. Use a minus sign. Okay, so use these rules. I think you've seen them before, but that should be enough for you to do your homework tonight. Okay, I'll use the last minute to give you the secret for these. All right. The key is in the almond salsa. That's a lot of ingredients. Definitely use canola oil instead of lard. You get some chilies de arbol. They sell them at Aldi. 6 garlic cloves. Oh yeah, lots of garlic. Slivered almonds. Tomatillos. Those are the green little kind of, they almost look like a tomato, but they're green. You boil those. You husk them. You take the shell off of them. You rinse them. Roasted bells. So this says store-bought. I personally roast my own bell peppers in the oven. Salt, water, extra virgin olive oil, red wine vinegar. I don't put the habanero in there. It's too hot. Blend all that up. That's your delicious salsa. Then you got your tortillas you warmed up. You got your feta cheese. Basically, all you got to do, where are they? Where are they? Look, sweet potatoes, feta, scallions, the delicious salsa. And these little things are corn nuts. Believe it or not, they give it the perfect crunch. Warm up your tortillas. This stuff is delicious. steal my link.